welcome back to Ms. Nicole Tutoring. We just covered some of the more basic functions and their differentiation rules. Now we're going to get into trigonometric function rules. To remind you, trig functions, as listed, are sine, cosine, tangent, cotangent, secant, cosecant, and some variation of those as well that we'll get into later on. In the next video, we'll do some practice, and after that, we'll get into some special case differentiation rules. So make sure you stay tuned for those as well. So let's begin. So the derivative of sine of u, and u is going to represent some sort of function or something we're plugging into this trig function, is going to be cosine of u times, this is where the chain rule happens, right, times du over dx. So basically we're saying cosine of u times the derivative of whatever u is. So for example, if our function is sine of x squared, our derivative, f prime of x, is going to be first cosine of x squared, we leave it as it is, and then we multiply it by the derivative, again, of what's inside the bracket, so x squared, which is 2x. And we're done. In the next one, we have the derivative of cosine of u, and the rule for that is negative sine of u times du dx. Again, we're applying the chain rule right here. So for example, if our function is cosine of x cubed, our derivative is going to be negative sine of x cubed multiplied by the derivative of what is inside the bracket, right, which is right here, x cubed, so 3x squared. The next rule, we have tangent of u. The rule for that is secant squared u times du over dx. Okay, I just want to remind you that secant is just 1 over cosine squared u du dx. Okay, this is a lot more appealing to look at, so we're just going to keep looking at the secant squared rather than 1 over cosine. Nobody really likes fractions. So let's do a quick example. If our function is tangent of, say, 2x, our derivative is going to be secant squared of u, and u is 2x, multiplied by the derivative of u, which is 2x, so times 2. Okay, cotangent. Again, cotangent is just cosine of u over sine of u, like so. So cotangent is just cosine of u over sine of u as well. And you could actually use the quotient rule, which we covered before, if you'd like to solve for this, or you could use the more basic rule for derivative of cotangent, which is going to be the negative cosecant squared of u du over dx. As an example, if f at x is equal to 3 cotangent of x squared, the derivative of that is going to be, again, we have a constant multiple rule, so we just put the 3 in front, we don't touch it, times negative cosecant squared of u, so we can put the negative in front, so cosecant times x squared here, and then we multiply that. Now we multiply that by the derivative of what's inside, which is 2x. Okay, now we have secant of u, Again, a reminder, secant is just 1 over cosine of u. So the rule for secant is going to be secant u tan of u times du dx, which is again the chain rule. As an example, and we're going to keep it basic here, if f at x is equal to secant of x, then the derivative of that is just going to be secant x times tangent of x. Now for cosecant, remember cosecant is just 1 over sine of u. Sine u, so the derivative of that is negative cosecant u times cotangent of u times du dx, which is the chain rule. Example, f at x is equal to, let's say, cosecant of x squared. Then the derivative of that is going to equal to negative cosecant of x squared times cotangent of x squared multiplied by the derivative of what's that repetitive u, right, in the brackets, which is just 2x. Great, so this is a bit of an intro to trig rules. In the next video, we're going to do a bunch more practice problems for these.